Okay, so welcome everybody. My name is Matthias Eckermann, and Director of Product Management, and we are talking SUSE Linux Enterprise from A to Z. The rules are that you are choosing the characters, and if you choose a character, you get one of those things here. 3 characters do not exist. For those, you are double paid, and some characters have one, or some characters have 2 slides. So we will hopefully find our way into that. If you have any questions, you can ask at any point in time whatever you want to know about SUSE Linux Enterprise. If I do not know, we will follow up with you later on. So that said, first character, please.
Q.
What?
Q.
Okay, Q. Okay, Q is about quality. SUSE has an automated quality framework called OpenQA. It's an open source tool which is not only used by SUSE, but also by other companies. It has multi-architecture support. It allows multi-machine learning, machine testing. It has a support for multiple hypervisors to be worked on. It can also used with images or for disk image creation. It can also be used not only in virtual environment, but also with physical hardware. And it has an automatic incident reporting into our Bugzilla so that the developers can directly work on. This has massively increased our capability of doing true QA on full installations of the operating system. And so we have more quality runs, QA runs, and we have a faster QA access because we can test the complete operation system installation with multiple options at any time. And so we get more out, and we get it out with a higher testing rate. Okay? Next character, please.
N.
Who said this?
N.
Okay. N is about NVDIM. That is a very interesting technology. You may have heard about this, or you may have heard about persistent memory. Persistent memory is a technology which bridges between a flash device and a RAM device, basically. And it bridges in the way that it can have multiple modes. Sometimes this is also called NVDIM, non-volatile inline memory module, because it is delivered as in the form factor of a normal DIM in the recent technology and systems. It supports 3 types of access in SUSE Linux Enterprise 15 and actually also 12 SP4. Memory addressable, block device, and a block device with file system. We increased the support level in 15 and 12 SP4, and actually SUSE Linux Enterprise has been the first enterprise operating system to fully support this. The value is that for our partners like SAP, but also Microsoft, it is interesting for database applications. You have an instant database recovery in case of either the system needs to be rebooted or the database software has to be rebooted. So this gives higher reliability on the database, faster restarts, and thus is also a benefit to the customers. Okay. Next character, please. No, first we had G. Who was that? Sorry. G is about GPU computing, machine learning, and AI. We just have started our approach into that, not saying that we do not support GPUs already, but we have started our approach here more with more people in this. So we have enhanced our capabilities in product management and also in alliances, because we really want to help customers and partners to accelerate the innovation path. So accelerating here means that we are working with the hardware partners, with all the hardware partners with respect to GPUs, but also with respect to FPGAs, that their customers have faster and better access to the technology, to the connection between the hardware, the operating system, and the application. We want to adapt faster, and we also want to help the data scientists, who are the most important people in designing machine learning and AI applications, to have a better access to these technologies, because what we see is that yes, there are ways to implement GPU computing, machine learning, and AI, but still there's a lot of manual work to be done for people to start with this. We want to make it easier. And then in the end, inject means that we want to inject these functionalities into our own software so that scheduling, for example, or control of failure, prediction of failure can be done much better in SUSE's technology going forward. Was that a V or a W? A V, okay. You got a V. Oh, sorry. Okay. I need to book out. So I cheated a little bit because I didn't only want to talk about virtualization, but I really want to talk about ubiquity, and virtualization is just a part of it. So for that, probably we should pay twice. Let me be more careful now. Okay, good. So ubiquity means that the software that SUSE provides is not only available on one hardware architecture, but on multiple hardware architectures. So we have x86 64, we have Power Little Endian, Z, and ARM 64-bit. The architectures are treated equally by us. You have seen this already before in our OpenQA framework. And the differences are based on business case and the capabilities of what we provide as software and extensions. The deployment of those can be on physical devices, it can be on virtual hosts, we can run our software as virtual guests, we can run in public clouds, to list here Amazon, Microsoft Azure, and Google Cloud. And certainly we also offer container engines, we offer container frameworks, we offer the container as a service platform with Kubernetes, which is also based on SUSE Linux Enterprise technology. And we also offer containers, prepackaged, minimized containers, which include SUSE Linux Enterprise base packages so that you can directly start with SUSE Linux Enterprise also running as a container. Okay, next character, please. T. Who was that? Oh, no, okay, you can keep it. You can keep it. I have enough. Better? Yeah, good. T is transactional updates. So if you think about normal operating system updates, that means you are installing into the running system. This means you have the old software and the new software at the same time in the running system. This is not always what you want. Transactional updates are a special form of an image-based update. So it's not an image-based update, that's the opposite. You really exchange images, you have A or B. With transactional update, what we actually do is we are installing the update into a additional snapshot of the operating system, which is a direct one-to-one copy of the running system, but the update is not impacting the running system, but it's really a separate snapshot. And only via a reboot, the transaction then is fulfilled, and the new installation and the updated installation is actually activated. So this is a technology that only SUSE has currently. It helps customers in the way that it improves the reliability of updates. Customers have more trust in the updates. And in the end, we hope that customers with this can more frequently update and this have higher reliability and also more security in their systems. Yes?
Is that done using the Butterifs snapshot?
Yes. It is basically a reverse implementation of the snapshots. So the normal snapshot in Butterifs works this way, that you first snapshot, then you install in your running system, and then you do a second snapshot. In transactional updates, you first do a snapshot of your operating system as before, but then you are not installing in your running system, but you are installing in the newly created snapshot. And then as a next step, this newly created snapshot is activated as the new default. And when you reboot, the system automatically knows that it needs to go in this formerly newly created snapshot. But you can also roll back as you could do before. So you can always roll back as well. And this is where this trust comes from. And this is how you have, can this more automated, and where you have real atomacy here, which others claim, but we think that this is real atomacy here. Good question, by the way. That gives another. So the problem here with throwing this is that the room is not high enough. So this is why this is problematic. Okay, next character, please. X. Who was X? Okay, you get 2, because I decided that this year I will not do X. Oh, okay. Okay, you got it? Good. What was the other question? The other character? K. K is good. We have K. Kernel and userland live patching. You see that this formerly was L, right? And actually, oh, the K is there. Good. So SUSE has introduced kernel live patching some years ago, which gives you updates for the running kernel without rebooting the system for security, stability, and data integrity issues. We allow these kernel live patching to be to run the system without interruption, without a reboot for up to a year, depending on which kernel you choose, and then you get these live patches for us. We are evaluating the option to do userland live patching because customers and partners approached us that they want to be able to live patch also our applications, our libraries, but potentially also, and this is where the live patching SDK in the future may come in, that they want to patch their applications also with a similar technology of what we are currently doing in the kernel. Yeah?
Do you get access to the live patching add-on during LTSS? Or
yes, that's also a good question. Let me give you another one. You actually do get up, if you have live patching enabled before, then you have access to the tools. And if you go into the LTSS phase, you'd continue to keep the ability of having the live patching according to your LTSS subscription.
even on the SAP SKU?
Yes, but you need the live patching. You need to have had the live patching before, because only then you can establish the live patching. And it's only up to a year with every kernel snapshot. So you have one kernel where you start, then you have a year, and then you really need to reboot. So you need to reboot once in a year. That's not possible otherwise, unfortunately. Okay, next character, please. W. I had a W, but I decided that I will not talk about this one, so you get 2. What do you get? Okay, next character. I. Okay. So I is a little bit difficult. The I. Who has I? You get an I, but an unfortunate, it's an H. It's a second H. So let's see at this. High performance computing. SUSE has a high performance computing product. And I decided to put this in case, I have a second H, so you can imagine. We have built this on SUSE Linux Enterprise. The real thing is that we have in this supported HPC module for x86 and 64 and ARM, we provide simple and reliable access to HPC tools that most people want. So the kernel is not specifically tuned for that, but this is a pricing deployment option, plus you have these tools that everybody wants or needs to deploy a high-performance computing in open source. And it is a true enterprise support and software that you get. So it's not like a community distro without support, but it's real enterprise OS and enterprise support from us, or enterprise support from our partners, which then is delivered by us. Also, this is available. Okay, was HPC. Any other character? So we have everything A to F. H, J, and more. J, who is that? Let me try this. Oh, better. Okay, so Just Enough Operating System, JUICE, is a subset of SUSE Linux Enterprise Server, very efficient for virtual deployments primarily. It's delivered pre-packaged. You can directly download from our download space. But it is a true SUSE Linux Enterprise Server with respect to certifications, the availability of packages, so you can install them later on, the subscription and the pricing, and also the policy. And the reason why we have done that is that it provides customers a quick start into the SUSE Linux Enterprise world, specifically in cloud and private cloud and virtualized environment. Similar to that, we also certainly provide, in public cloud environments, we provide pre-packaged installations of SUSE Linux Enterprise that you can directly run. That's a given anyways. Okay, next character.
N.
We had N already. Should I do M?
M.
Multimodal OS. Who has heard about bimodal IT from Gartner? Okay, so bimodal IT is a little bit of a black and white world, and probably too black and white. So what multimodal IT means, it means that there is a continuity between a traditional data center and a data center which is driven very agile or based on DevOps principles. The reality is that most customers have both or a mixture of these. And with a multimodal OS, we mean that we have on the one side capabilities such as live patching, which are truly mode 1, so very old-fashioned, traditional, reliable. But on the other side, we enable our customers to run with modern technologies like container engine in SUSE Linux Enterprise Server is available. Web and scripting packages, modern programming languages are available. Access to Git is certainly also included. So we are bridging the worlds with a multimodal OS, and we have developed from a monolithic operating system, which was SUSE Linux Enterprise 11, over a modular operating system that was more the 12 to a modular plus or multimodal OS in SUSE Linux Enterprise 15, where you also see that we include SUSE CaaS platform here because it is based on SUSE Linux Enterprise Server technology as well. Question, yeah?
So does that mean on the modular section, you're enabling folks to run containers on SLES without Kubernetes, just as
Yes, we have this as well.
lightweight virtualization?
Yes, so we have a container module in SUSE Linux Enterprise Server, and this container module has a container engine, and with this container engine you can run containers just as a single node, but without Kubernetes. And if you want Kubernetes, then you need to choose the SUSE CaaS platform, which has Kubernetes, which has a cluster deployment mechanism, so that is much more efficient for you to really run and scale these container worlds.
Do you have tools to help customers take their monolithic apps and encapsulate them as a container?
We have a little bit of these tools, but I'm certainly not the biggest fan of it, because you really need to consider if it is a good approach to containerize a monolithic application. And the problem here is, which is called cloud native applications. A container infrastructure, and specifically a Kubernetes infrastructure, is specifically thought for applications which can start or die at any point in time. So there is no data that really should be in these containers. If you have a classical monolithic application, then you need to specifically configure your Kubernetes cluster to be aware of this application not to be kicked down or killed at any point in time, because your application really would not appreciate that. So from my perspective, the more reliable start into a container world is looking for container deployments first in a cloud-native world. Certainly, there are tools to do that. We include like basic tools to help you to package existing applications. Yes.
Any thought to converting like VM images into container images?
The answer to that is that from my perspective, on the one side, both containers and virtualization are virtualization. The one is hypervisor-based virtualization. That's what we call virtualization. The other one is OS-level virtualization. That's what we call containers today. But virtual machines and containers serve completely different use cases. With the virtual machine, you are virtualizing a complete operating system, which includes one or more applications. With the container today, you are virtualizing OS-level virtual, you are virtualizing or packaging one application or one service into a container, and this is really a different approach. So imagine if you have a classical application that you are virtualizing, you package the whole application into one VM usually. But in a container world, you would potentially split this application out into 5 or 8 microservices, which each would get their own container. So that's why I say packaging directly repackaging from a virtual machine into a container needs an architect who looks at this if this is the right thing to do or not. And this really depends on the application. We have discussions with some partners about these things where they are looking at potentially repackaging existing applications, but that's something that really is a case-by-case basis, not something that we have a general case for. So the question is what the most common deployment for the modular approach is. So the modularity is really to help customers with respect to the life cycle of packages, because specific packages need a more aggressive upgrading and updating strategy. And with respect to that, the modular approach helps us to clearly define the life cycle of modules and packages. So that's it. It does not depend on actual deployments. It more depends on life cycles of specific technologies which are used in mode 1 or mode 2 worlds. Okay? I have everything from A to F, H, L, O, R, S, and Z, and U. D? The developer, you have zone, you have heard Thomas today talking about the DevZone, and we have people who really care about developers and the SUSE developer program. What we want to do with this is that we study and identify the needs of developers and also trends, that we take these into SUSE with dedicated people who are working on this, and that we are building the respective relationships to the people. This is necessary because we already do have this in the open source community, but we do not necessarily have this on all levels. And we have figured that some of our customers may not get the right help from us in developing applications in-house. And there are large companies, a lot of those, who are developing applications in-house. So we want to help them, these customers and the developers, to improve the experience and also to increase the productivity by getting the right tools, and that goes back to the multimodal approach, by getting the right tools into the products, the right approach with the right life cycle and the right support promises on these tools and also on the framework and documentation. Okay? Others? Next character? You? Okay. The SUSE Unified Installer in SUSE Linux Enterprise 15 is unique in the sense that we, first time, not only have products from SUSE Linux Enterprise in it, but we also include SUSE Manager and SUSE Manager for Retail. The reason for that is that SUSE Manager and SUSE Manager for Retail is based on SUSE Linux Enterprise, and in former times, people had to download a SUSE Linux Enterprise Server DVD and a SUSE Manager DVD. And we found that in a world where most people live online, the best approach might be that we have a unified installer which offers all installation options with SUSE Linux Enterprise, SUSE Linux Enterprise Server, SUSE Linux Enterprise Server for SAP applications, high-performance computing, real-time, but also the extensions which are included, like SUSE Linux Enterprise Server plus HA, or SUSE Linux Enterprise Server plus SUSE Manager. And so this is how we came to the idea to have a unified installer in the SUSE Linux Enterprise world. This is a snapshot from 15 SP1 RC1, so just very recent. And we will ship this we shipped this already in 15, and we have extended it with SUSE Manager in 15 SP1. We also allow offline installations, so you can basically download everything which we offer online, also as a huge offline DVD. It's about 8 gigabytes, but should be no issue in these times. So this helps customers to get a quick and easy access to the full bandwidth of the SUSE world, SUSE data center world, where you then can start off specifically as SUSE Manager also helps to manage other parts of the SUSE product world. So you really get a good starting point here with an operating system and the management tools together in the data center world, but also in the retail world. Okay. A, B, D, whatever do you... Z or Z? Same thing. No. There is C, Z, and Z. Okay, Z. Good. That is about zero downtime. Sorry. It's always, you get an extra one later on. So zero downtime has been a campaign of SUSE some years ago, but the real point is that we want to offer the full framework of driving business critical applications for our customers and partners. And this has 4 pieces, 4 primary pieces. RAS refers to the availability of hardware and to the enablement of the hardware in SUSE Linux Enterprise. Full system rollback, we already discussed that, the rollback piece when we talked about transactional updates. Full system rollback means that even the kernel is covered by a system rollback, which sometimes helps, and I've heard specifically from people who are running OpenSUSE that sometimes when they get very quick updates, which might crash their systems, which we don't see in the enterprise world, fortunately, that this helps them to recover. We have high availability in geo-clustering. I may talk about this later, and we already talked about live patching, kernel live patching specifically, but also upcoming potentially the userland live patching, depending on where we get with the technology. Next character? Z. That was that. Very funny. Okay. Because of the joke, you get a C now. And C is about compliance and certifications. So we have several certifications on several levels. We have security-related certifications like common criteria. We have compliance mechanisms like the US DISA stick, which helps a customer to verify that the system is really installed and configured according to the guidelines of the DISA. We have validation of the federal implementation standard FIPS 140-2. We run compliance for IPv6 according to the USGV6 standard. There is a test lab at the University of New Hampshire which does that for most people in the world. And we also have our own certification, YES certification as a good name here, traditional name I would say, because we want to help our hardware partners to ensure to the customers that the hardware that they produce really works with our operating system and vice versa. Yes?
How often do you run FIPS certification?
Okay, good question. Let me try to do that properly now. Okay, we run the FIPS certification. We have started to run it more often than in the past. Let me put it this way. So the original attempt was to only run it once per major operating system version, but we learned that this is not enough and that is not good for the customers because they have to qualify the compliance with the authorities more often. Our current plan is, and we have done this a little bit in 12 already, that we keep the packages which define or which are under the FIPS 140-2 compliance, that we try to keep them for at least 2 service packs so that you always can, for example, install the OpenSSL of 12 SP2 on 12 SP3, which gives then the FIPS compliance for this package. And that then we undergo a FIPS recertification. And this is currently how to say that in proper English? We are currently running the process for SUSE Linux Enterprise 15. So we are in the planning phase for doing common criteria, STIG and FIPS for 15, which includes the plan to do the FIPS certification much more often, so that always, so definitely every 2 years we have a full compliance set available. For 12, we were not too bad. We can always do a little bit better. Fortunately, there has also changed something in the FIPS area. As a little bit background, common criteria allows you to apply updates to the operating system and still remain compliant. You are not certified, but you are compliant. And if you have seen a common criteria certification, it's usually with this EAL 4+, and this plus in our case exactly means this flaw remediation addition there. And this means that we have certified our update process so that we can comply for common criteria. Up to 2 years ago, this option was not available for FIPS. You always had to certify one FIPS package binary-wise. If you change 1 bit in this package, then the FIPS certification was gone. This changed. You can now undergo a lightweight FIPS recertification process if you, for example, apply security fixes to a FIPS package. This helps dramatically because in former times you had the choice about either be compliant or be secure, obviously not what you want. Nowadays you can be compliant and secure, and this on our side also requires some changes to our internal processes so that we can prove what we actually do. We can prove this today, certainly, because it's all open source and we have the log files, but we need to prove that in a specific way, and we have to implement processes to show this to the authorities so that the recertification is quicker. That's actually a very good question. Thank you for that. Yeah?
We just went through the common criteria, and our certificates only good for 2 years. We would have to recertify in 2 years, and the common criteria changes every year.
No. Common criteria, so FIPS, so the change, the certification itself, and so we need to differentiate between certification and compliance. The certification always only is true for one specific setup of the operating system, specifically with common criteria. The compliance to the certified set, though, is better with common criteria. You can update, and the certificate for 12 is, if I'm not mistaken, valid until 2022. So these certificates are, the certification for common criteria is valid longer, and due to these plus there, our ability to update, customers can remain compliant even if they update parts of the operating system. This is very important because you cannot recertify every year. This is not, nobody does that and nobody wants that, not even the authorities, because it's a lot of work on all parts involved. So the general attempt by all operating system vendors in the enterprise space I'm aware of is that you do a full certification once per major release, and then you do partial recertifications where necessary, so where you do a substantial change to the package, then you need to recertify. So in the case of FIPS, for example, the OpenSSL packages can live for 4 or 5 years if there are no major flaws in them. But the Linux kernel, because we update it every other year in our service packs, the Linux kernel needs to be recertified, re-evaluated according to FIPS every second year to remain full compliance, or customers have to install the old part of the operating system, the old version. Yes?
Somewhat related?
Yeah?
Because an OS can't be PCI DSS compliant, but do you have tools that help people
Yes.
achieve and maintain PCI DSS compliance?
So the question is about PCI DSS compliance. That's the payment card industry standard. PCI DSS compliance is not for the operating system. The PCI DSS compliant is for the complete environment where you do your financial transactions. We have actually a security guide, which is a 400-something pages book, and this has a long chapter about how to achieve PCI DSS compliance with SUSE Linux Enterprise. So there is some help, and if you need more help, SUSE has a consulting group with people, experienced people who have delivered PCI DSS compliant implementations already for customers around the world.
But no automated scanning tools and things like that to verify.
I'm not aware if this is possible, but we can take this offline. Okay. We have B, E, F, H, L, O, R, S. What?
Victor. V as in Victor.
We already had Victor. What? L? Okay. L is about life cycle. So the life cycle for SUSE Linux Enterprise 12 and 15 is 10 plus 3 years, if you are potentially aware. And these boxes here show that we support that you are staying with an operating system, specific operating system version much longer into the LTSS space, but nevertheless, you are supported by us to either skip one, to either go to the next service pack, or even skip one service pack, so that you can really have a full migration path and can continue to run. For example, you stay on every version that you are on for 3 years, and then you can jump one service pack and be fully supported during the migration process and also with the operating system at any point in time. The current plan is for 12 and 15 to have 5 service packs. We may have 6 for 15, but this is not yet fully decided. And even after these LTSS time, LTSS means long-term service pack support, there are options for customers who really want to have one operating system version supported longer than 13 years, or a specific service pack to be supported longer than 4.5 years. This goes down to negotiation with us about so-called reactive support. Important to have such a roadmap from my perspective is that customers have predictability in whatever they want to deploy, and that it is visible that there are real long-term support options. Regarding predictability, one important addition to make here, we really plan service packs every year. You see that, you have seen that in the last years. 12 always came out end of the year. 15 so far came out mid of the year. Next year will be the first one where we only will have 15, but the current plan is also to deliver this at the mid of the year. Questions to the life cycle? Yes? That is an interesting question, because I have heard this claim before, but there is no proof SUSE internally for this claim. So I got this claim from the outside, but I don't know where it comes from. It's not true. So we really only support n+2, so from n and n+2, but it's from n to n+3 is nothing we currently support. If you have really special needs, then please come to us or talk to your SUSE contact, and we need to discuss this. So sorry for that, but I've heard this before, but I'm totally surprised, and I did some research some months ago where this comes from. I couldn't find out. When we look at this, also considering that SUSE supports major version upgrades since SUSE Linux Enterprise 7, so 7 to 8, 8 to 9, and that other operating system vendors just currently make a big fuss about major version upgrades in place, that gives you hopefully the view that we really take this serious, that customers want to continue with their deployments and not have disruptive upgrades. So that, yeah, please come to us and let's talk about what you really need. Okay. I have A, B, E, F, H, O, R, S. B, my preferred one. My colleagues love. The room is really not high enough. So Butterifs is a file system. It is a copy on write file system. So it's a little bit different from other file systems. Copy on write means when you write something, you are not overwriting what is on the disk, but you are getting a new chunk on the disk where you write the new data, and then just the pointers are changed. This gives you more reliability. And in addition to that, we have checksums for data and metadata. Also, this is something that is not all file systems have. This is why we have chosen it as the default for operating system and containers. Additional functionality that Butterifs offers compared to other file systems that do not offer this is in-place compression. It is deduplication capabilities. That's the direct functionality of this copy and write functionality. And we already have discussed that we have rollback to a well-known state. We have discussed that transactional updates depend on it. And also something important, rollback for service pack migration also works. So compared with these, or combined with the functionality to jump a service pack, if this jump would fail, hopefully not, you could also jump back and really have your old kernel, your old configuration, and then directly go from there. So it's a modern file system. It's reliable. It has reliability features that other file systems do not have. And it is also very efficient. Compression is one thing, but also so-called tail packing for small files is another thing. I wanted to bring a use case why Butterifs is also useful if we are looking at containers. And I promised when I announced the session that we talk about containers a little bit. When you're looking at containers, a traditional stack for implementing containers has 7 layers. So you have a physical device, you have a partition, you have a PV in the device mapper area, you have a device mapper volume group, you have a device mapper logical volume. On this you have a file system, and then you use an overlay file system. And in this overlay file system, there the container chunks are in. In Butterifs, it's a little bit easier because all of this here, from the PV to the overlay file system, you can basically implement using subvolumes in Butterifs. So you only have the physical device and its partitions. The rest is done in the Butterifs file system. And on top of these subvolumes, you are really implementing the single container or the single container layers. That's actually what the SUSE CaaS platform does when you are deploying it physically. It helps to reduce complexity and for that also improve the scalability of the whole thing, because when you think about overlay file systems, for every layer you need a different mount point that can become quite complex quite fast. Okay, questions? Next character, please. I have A, E, F, H, O, R, S. Nobody? S? S talks about system roles. I apologize for this small screenshot. It is also functionality which we have introduced in SUSE Linux Enterprise 15. Imagine that you have different types of installations that you want to do. You have application service, you have database service, you have web service, you may have a file server. And for all of those, you need different patterns. You need a different file system layout. You may need different users that are standardized on this. So with system roles, we give, let's say, a selection of specific settings that we think a majority of customers need. Here we see / with GNOME, that's just for desktop. Transactional server, it's in SP1 as a tech preview. Text mode installation, so quite minimal. Then real minimal. Then we have a KVM virtualization host and a Xen virtualization host. That's the prepackaged options. Also, these system roles are used when you install a SUSE manager. You also have 1 or 2 system roles that you can choose from how this is done. In a little bit simplified saying, we make best practices that we learn from our customers and our partners available to all customers with these pre-selections of user settings, partitioning settings, and package selections. Okay. Anybody wants to choose, or is it too riskful if I throw these things away? R? Good. That's quite easy. It's directly before. R talks about RMT. This tool was called SMT before, subscription management tool. RMT is the new version of it. And I reused the same picture so to really show that this does the same thing. It is a proxy, a package proxy. And the important thing for this is certainly saving bandwidth. If you have 100,000 systems at the same time going to the SUSE Customer Center, neither your network connection nor the SUSE Customer Center is happy. If though you have a distributed setup, or if you have a SUSE Manager internally and want to download all the packages before you bring them into SUSE Manager, this also works with RMT. The good thing is you can have this as the only single point going through the firewall to SUSE Customer Center, while all the other SUSE Linux Enterprise systems do not need to cross the firewall to get updates. They just get them internally. Our recommended way of using it is really using RMT for getting the packages. You can also get these into an offline network, so a sneaker net in between, so you can export them from one RMT and import into an internal RMT, but then internally using SUSE Manager to really deploy things and manage them better. So from my perspective, the real thing about RMT is making it easier and faster to get packages into an internal network, manage this compliance, security boundaries, crossing a firewall, and also allow a little bit of reporting and management. Should be combined with SUSE Manager at any time. Okay, we have A, E, F, H, O.
A.
Who was that?
A.
Okay. Try better. Good. A actually talks about something you may have seen and may see in also other presentations here at SUSECON. It calls about the application delivery and software-defined infrastructure framework that SUSE has. And here specifically the position of SUSE Linux Enterprise in this framework. Because there is one important thing with SUSE Linux Enterprise. It's not only the oldest part of this whole application delivery and software-defined infrastructure framework, but it also creates what we call the common code base. Common code base in different directions. Common code base in the meaning that we have a common code base across all architectures, that we have a common code base across all deployment methods. So it goes a little bit into the term of ubiquity. Common code base, though, also in terms that all the other products, in the one or other way, some more, some completely, some others lightweight, depend on SUSE Linux Enterprise with respect to the packages. So for SUSE CAS platform, I already said this. SUSE CAS platform runs on a true SLAS. It's called macOS and CAS version 3, but this doesn't matter. It is a SLAS from the packages. There are the same FIPS packages in there. For example, SUSE Manager is built on a true SLAS when you install it today already, but also going forward. SUSE OpenStack Cloud reuses some packages of SUSE Linux Enterprise, certainly, and we in turn have taken packages into SUSE Linux Enterprise Server which are used or needed by most of these other products from SUSE. Because once we see that a specific package is used 3 or 4 times, it really makes sense to bring it into the common code base. So this has advantages for customers, though, because we get better compatibility between those products. We get more quality, because if those packages are always common, they are tested in all different circumstances or connections. And obviously, we also get a little bit better stability throughout the whole stack if you have tested these things, how they work together already up front. Okay. Now let me go to 9 and eat it myself. No, who wants the E?
F.
Who wants the F? Good. F is about file systems. And as you know, I'm a Butterifs fan, but I'm not only a Butterifs fan. I am actually a fan of using the right file system for the right choice. And this is what this graphics is about. It is about how to define which file system you should choose when you do something. If you want a new file system, then the purpose is the use case is what you really should decide upon. For the operating system, we recommend Butterifs. You can also use others. For the data, it really depends on what you want to do. If you need snapshots or containers, as discussed before, then our choice is Butterifs. But if you don't need snapshots, our recommendation is XFS, which actually SUSE supports also already since 2002. When other people didn't even think about XFS. If you have an existing file system, then it really depends on the type. So if you are a /10 or /11 customer, then you want to go with XFS, and you have XFS, you can just keep it. If you have RiserFS, because you are such an old customer, well, this is not supported anymore in 15, but you have the choice to convert it. And if you have ext2, 3, or 4, it really depends on your applications. If you want snapshots, same thing. If you don't want snapshots, then you keep it because it's still supported. If you want and need snapshots, you can also convert it into Butterifs because there's a direct supported conversion path from ext2, 3, and 4 and RiserFS into Butterifs. But as said, it's not that we force you into this, but that these are the options that you have, and our framework gives you even more options. We have a little bit of a recommendation depending on the best use case. This is taken from an older presentation from mine at SUSECON. If you want to have deduplication or container host, and for the operating system, due to the snapshot rollback functionality, we really recommend Butterifs. If you have databases or a file server or a home directory, then the choice of most customers will be XFS, and it is a perfect choice. If you have a virtual machine host, also XFS is the recommendation. For everything you want or need snapshots, you certainly will use Butterifs because it gives you better capabilities. Yes, Patrick?
So Butterifs has native snapshots available to it, but there's a lot of third-party applications that do backup and recovery that do their own snapshots. They
Yes.
struggle with Butterifs.
Yes.
Are there any plans to make APIs available so that Butterifs can be utilized by those third-party snapshotting tools?
So that depends. For classical virtual machines, we really recommend that you use XFS because the level of integration is a different one. You can hardly use the same technology for snapshots. But there is an interesting aspect where you ask. We have a customer, actually a big customer, who uses Butterifs for backup of virtual machines. So not for running virtual machines, where we really recommend XFS, but for backup, not due to the fact that he wants to use snapshots actually, but because of the deduplication effort that otherwise would be huge. But with Butterifs, they can really save a lot of space because all these different backup systems that they have. So my perspective is that Butterifs, well, I like it, as many people know, but it is a fact that there are use cases where you better choose XFS. I really personally do not recommend ext4 because it is in the industry, in the Linux industry, currently a little bit on the way out of the common use, with us focusing on Butterifs and XFS and others focusing on primarily XFS. This is where you really get the stability and the investment into. And we are investing into other areas in Butterifs as well, like enhancing the compression or also enhancing the rate levels that Butterifs has so that you can have easier deployments with even higher reliability there. But actually a good question. And you should get something for that question. Later. Good. So I have E and O. So who wants to get the E? Nobody wants an E? Okay, I eat it my own. Okay. E talks about the SUSE Linux Enterprise extension, that goes for me, where we have not so many. In other operating system vendors might have much more extensions. But there is a reason why we do not have so many and even reducing the number of extensions. Like, for example, in the high availability extension, we have now included the GeoCluster extension because we really found that it is, for customers, difficult to juggle with too many extensions and too many SKUs that they have to buy or purchase. So this is really done per use case that you have. If you want to do live patching, you get an extension. If you want to have high availability capabilities, then you have this, and you have all the high availability tools on storage, on load balancing, and on availability in one package. Virtual Machine Driver Packs talks about Windows integration into Linux virtual machine hosts. So we deliver tools for Windows running virtualized on Linux. The workstation extension is what I'm currently using here with SUSE Linux Enterprise 15 because it delivers LibreOffice, it delivers Evolution for integration with Exchange servers, and the long-term service pack support that we already discussed as part of the life cycle. That is also an extension, if you want to say. It's a non-technical extension. There are no additional packages, but it's a life cycle extension. And in that case, it's also an extension. And with that, let's go to
workstation is not a cheaper subset SKU.
No. We also have the we also have the desktop, but the desktop is really a cheaper one, but it doesn't have many of the server tools. The workstation extension is really an extension to the SUSE Linux Enterprise Server.
So there's different bits in the desktop stream?
The desktop stream has less bits. So basically the difference, so typical server implementation pieces like KVM or Xen are not in SUSE Linux Enterprise Desktop, And if you want to build a VDI infrastructure, then you should use SUSE Linux Enterprise Server plus the workstation extension, because then you have the full server capability. Yeah, and I guess I would like to end. We talked about high availability already. I would like to end with the open build service, because it is the heart of what SUSE does, and with the package hub. It is the heart of what SUSE does in terms of software development. This is an engine. It's open source software where our community and us are building all the packages. And as you see in these colors here and these logos, we are not only able to build packages for us and our distributions and the versions of it and all architectures, but we are also able to build software for other Linux distributions with it. And we are open that everybody uses this for open source software in a free way. It's a hosted service that we are offering, and we know that around 100 partners around the world are also using the open build service in-house to build their software. The most prominent I can talk about, because it's also an open source operating system, this is Samsung with Tizen. They also are using the open build service to build Tizen as an open source Linux-based operating system. And last, I would like to end with Package Hub and Partner Hub. This is where the open build service, SUSE Linux Enterprise, and the community work really comes together. Package Hub is a collection of supplemental open source software for SUSE Linux Enterprise, supported and provided by the communities, but in the open build service recompiled for SUSE Linux Enterprise, and thus broadens the package choices for enterprise users. And Partner Hub is something that doesn't exist yet, but where it exists already, but not with this name. It exists already for SUSE Linux Enterprise Server for SAP application users. It's called SUSE Connect there. It allows customers, we provide metadata together with software partners, and it allows customers to install these third-party software with 2 or 3 clicks very easily, directly from YAST or from the command line. We will broaden this in the future in an App Store-like approach, and then the name may change. Most common name thinking currently is Partner Hub, so that we simplify the installation of third-party software on SUSE Linux Enterprise Server, and still customers have a full integration into the SUSE Systems Management Stack, so much easier, so that communities basically here, the open source community and the ISV community, come together in a very similar approach, so that the value for the customers is real choice between open source and commercial software, and it's ease of use in the end that we provide with this. With that, I thank you for being here and helping with choosing the characters.